Good morning. Welcome back. So, last class we did deletion of the last node in a linked list. So, we are done with the linear data structures, that is arrays, stacks, queues, and linked lists. I did all the algorithms as well as the program associated with it. We are done with all the lab programs wherein I have shown you the writing the program as well as the execution of it for data structures. And now we'll do non-linear data structures. Non-linear data structures, what do you mean by that? The data structures, if its elements form a hierarchical relationship. That is, a nonlinear data structure is a data structure which exhibits either a hierarchical relationship or a parent-child relationship. That is, if the relation, by seeing this, see, this is a tree, it has got branches, so it is hierarchical, one above or below. It's not continuous, it's not linear. That is why it is called non-linear data structure. So, a non-linear data structure is one which exhibits either a hierarchical relationship or a parent-child relationship. The trees and the graphs are for you don't have any programming in this. They'll ask you to name two nonlinear data structures, or they can ask you definitions of few, like it can come for 3 marks, wherein they will give you to define 3 terminologies used in trees. So this is how a tree looks. You will have a root, and then the elements are arranged into the right subtree or the left subtree. There are different branches in a tree. So there is a hierarchical relationship or a parent or a child relationship between the elements. So that is why it is called a non-linear data structure. And then a binary tree can be represented in sequential representation using single dimensional array or linked list representation using a doubly linked list. Fine. So it's a non-linear data structure compared to arrays, linked list, stacks and queues, because arrays, linked list, stacks and queues are linear data structures where trees and graphs are non-linear data structures wherein the elements have a hierarchical relationship or a parent-child relationship. So, this is how a tree looks. I will tell you what each one of it. It's a very important question. They will definitely ask you the definitions of this. So make sure you learn all the definitions properly. So what is a tree? A tree is a set of nodes storing elements such that the nodes have a parent-child relationship. So each one is a node, right? Each one is a node wherein a tree is a set of nodes. Yes, you can see so many nodes are there here. Root, then parent node, child node. So you can see leaf node, siblings. So all these are different terminologies used in a tree. When you have the subtree, or you can have subtree on both the sides of the root node. So a tree is a set of nodes storing elements such that the nodes have a parent-child relationship. So now we will learn few terminologies of trees. So these are the few terminologies which I have labeled here also. The first one is a node. A node is a fundamental part of a tree. Yes, it's a collection of nodes, right? Organized in a hierarchy, wherein the nodes have a hierarchical relationship. So we should know what is a node. So a node is a fundamental part of a tree. Each element of a tree is called a node of a tree. It stores data and has links to other nodes. If you are using linked list, you will be using doubly linked list representation. A node is a fundamental part of a tree. Each element of a tree is called a node, right? Each element of a tree is called a node, and then it stores. What does the node store? The node stores data, or nothing but data is nothing but information, and has links. That is, with the help of links only you can traverse the tree, right? Otherwise, how will you traverse? You cannot traverse, that is, move from one node to another. So a node will store information or data, and as well as it has links to other nodes of the tree. That is a node. And next is root. The top node in a tree is called a root. Root is a special node in a tree. The entire tree is referenced through it. It does not have a parent. So as you can see, there is no nodes above A. So A is the root. Everything is below A. So A is something which does not have a parent, and the entire tree, yes, you can reference, or it has connection through the entire tree, right? Entire tree can be referenced through it, and it is a special node of the tree, or I can say it is the top node in a tree, is the root. Next is parent. So what is a parent? A parent is an immediate predecessor of a node. Predecessor is before that. Suppose here I can say D. So immediately before that, predecessor of D is B. So B is the parent of D. That is what it means. Parent node is an immediate predecessor node. So a successor, what is a child node? A child node is nothing but a successor of a parent node is called a child node. Successor is after, right? Who is your successor is who's after, who will take over the charge from you. Predecessor is from whom you have taken over. That is, B is the predecessor and D is the successor. So B is the parent node and D is the child node. And then you have siblings. You know what is siblings? Nodes that are children of the same parent are called siblings. Can you tell me siblings? The parent supposes A, then B and C are the child of the same parent. So they are siblings. Siblings are nothing but the nodes that are children of the same parent are called siblings. Here also you can say D, E and F are siblings because they are parent of B. Sorry, they are children of B. B is the parent. Next is leaf or terminal node. Leaf or terminal node, you can see leaf node over here. The leaf, or it can be also called as terminal node. A node is a leaf node if it has no children. So definitely G has no children below that. That is why a node is called a leaf node if it has no children. Leaf nodes are also called as terminal nodes. So if they ask you what are terminal nodes, you need to write the definition as a node which does not have any children. Like if it does not have node without any children is called a leaf node or a terminal node. Getting it? Next is internal node. A node which has one or more children are called internal nodes. A node which has one or more children. So here I can say B, C, E are called are internal nodes. That is, a node which has one or more children is called as internal nodes. Path. So what is a path? A path is an ordered list of nodes that are connected by edges. So what is an edge then? Right, a path is a number of successive edges from nodes to destination is a path. If I say that is a path, then what is an edge? You should know what is an edge. An edge is, it connects. What does the edge do? It connects two nodes to show that there is a relationship between them. Every node except the root node, except like excluding the root node, every node is connected by exactly one incoming edge from another node, and each node may have several outgoing edges. You can see here one incoming edge from here to here, but you from B you have outgoing edges, several outgoing edges. For E also you have one incoming edge from B, but you can have more than one outgoing edge. That is, this is the edge. That is, it connects two nodes to show that there is a relationship between them. So now what is a path? A path is an ordered list of nodes that are connected by edges. That is, a path is a number of successive edges from source node to destination node. If I have to go to E, then how do I have to go? A to B, B to E. So that is an edge, this is an edge. That is a path. Next is height of a tree. Height of a tree is nothing but height or depth of a tree is defined to be the maximum number of nodes in a branch of a tree. Height of a node represents the number of edges on the longest path between the node and the leaf. You know what is a leaf? A leaf is one which does not have children. So it will be the last. So from the first to the last node, the number of edges on the longest path is the height of a node. Height of a tree represents the height of its root node. That is, from the root to the last leaf node, the longest path, the number of edges is the height of the tree. The height or depth of the tree is defined to be the maximum number of nodes in a branch of a tree. Next is, what is the degree? Degree of a node represents the number of children of a node. So number of children, here B has 3, right? So the number of children, degree of a node represents the number of children of a node. H we already did. It's the connection between one node to another. It links two nodes or a node and a leaf. It can be a node and a leaf. Basically connecting two nodes wherein that node can be a leaf node. Leaf node is nothing but a node which does not have any children. So next is a subtree. You can see subtree here. A subtree is a set of nodes and edges comprised of a parent and all the descendants of that parent together would form a subtree. That is, a subtree is a set of nodes and edges comprised of a parent and all the descendants of that parent. Not talking about the successors here, I am talking about the descendants. A descendant, a node reachable by repeated proceeding from parent to child, is a descendant. An ancestor, a node reachable by repeated proceeding from child to parent. And descendant is from parent to child, and ancestor is from child to parent. Next is a binary tree. What is a binary tree? A binary tree is an ordered tree in which each internal node has maximum number of two child nodes connected to it. So, what do you mean by an internal node? A node which has one or more children is called as a internal node. So a binary tree is a tree in which each node has most two children nodes. Two child nodes should be there for each node. A binary tree consists of a node which is the root node, left and right subtrees, and then you also have a complete binary tree in which each leaf is at the same level and distance between from root to all the nodes have maximum two subtrees. So that is a tree. Next is the graph. A graph is a mathematical non-linear data structure capable of representing many kind of physical structures. A graph is nothing but, what is it? It's a graph is a set of vertices connected by edges. I can say a graph is a set of vertices and connected by edges. A graph is made up of two parts. The first is a set of nodes which are commonly known as vertices in a graph terminology. The second part is a set of interconnections between the vertices then called the edges. What happens in general? A graph allows an edge to connect any pair of vertices. So those are graphs, and we have come to an end of the data structures chapter. We have done both theory as well as the lab syllabus of data structures, and during homeworks I have also given you the exam asked questions from data structures. It is like 14 marks theory and 15 marks of lab. So hope you have understood that. Don't forget to learn the definitions in trees. Now we'll be starting with the lab programs. As I said, we have done all the data structure lab programs. Now I will show you the execution. We have already explained you the writing part of it whenever I have done the theory, but still I can, while going through the program, I'll just tell you the explanation of it. We'll be starting with the lab programs, that is section A, which is nothing but C++ and data structures. So the first program in the lab manual is to find the frequency of presence of an element in an array, which is a data structures program, which has already been done and I have shown you the execution. The second is an insertion of an element in an array, which is again a data structures. The third program is the deletion of an element from an array at a given position. Fourth is the sort the elements of an array in ascending order using insertion sort. The fifth program in the lab manual is write a program to search for a given element in an array using binary search method. All these programs are data structure ones which is already done during the lecture. Whenever that particular thing has topic has been done, I have covered the writing part, explanation, trace and execution of that. Here I will be doing the sixth lab program, which is write a program to create a class with data members, principal, time and rate. Create member functions to accept data values, to compute simple interest and to display the result. This is your sixth lab program. Please make a note of the statement. Then I will show you the execution of it. While doing that, I will take you through the program and explain it also. So many a times in the lab manual there may be minor mistakes. So please make a note when you are going through that. Please make a note of the statement of the program and try to write it on your own or understand and execute it. Don't mug it up, because many students have seen when they mug up the program, when there is even a small mistake of comma, colon, dot, you're not able to debug it and you will be sitting in the exam hall wherein you can easily get marks. So understand it, then you can do it on your own. Please make a note of the program statement, then I will take you through the execution of it. This is your sixth lab program, which is nothing but to calculate the simple interest. But then please don't write void main programs, because they have explicitly specified that you need to create class, create data members and create member functions. So stop having that practice of writing void main programs, everything in the void main. No, it doesn't work that way. And don't write programs with standalone functions also, only like I will have a simple interest function and then I will call it. No, you won't get any marks for that. When they explicitly specify that you need to create class, then data members and member functions, you need to do it in that way only. So hash include iostream.h, conio.h, we know why we use it. Here class is a keyword and name of the class is simple interest. I have given simple interest. You can give whatever name you want, but then it should be a proper name or a relevant name to what you are doing. Don't give any name which is not related, like don't give unrelated names. Definitely it will work, but when you see the program, anybody who sees this should be able to understand what it is doing. So you should have proper see out and see in statements. I have seen many students having like directly you take in the value, see in statements are there, but I don't know as a user what I need to do, because when you don't give any see out statements, the user will have no clue what the user should be doing, like what he needs to enter, one value, two value or three values, or what exactly values he is entering. So the program should be written in such a way that it is should be executable by all. So make sure you write proper see out and see in statements along with inserting lines wherever necessary. So here I have class is a keyword, simple interest is the name of the class. After that, I am opening the class in the private section of the class. What is private and public over here? They are access specifiers. If I don't specify anything, but still it will be private only. The default access specifier of a class is private. Anything declared in private section can have both data members and member functions also. I can declare a member function in private. The only thing is I will not be able to execute it or call the function outside the class, because outside the class I will not be able to do it. What I need to do is I need to call that function in another public function of the class. So when I'm calling or executing the public function by creating an object and calling it, which in turn will call the private function, that I can do. I will show you that also how I can do. So private float, I can either you can have float or double. If you want to calculate for a bigger number, make it as double, otherwise it is float over here. P, R, T and SI. What are these? Principal, rate of interest and time period. And SI, I am using it for calculating the whatever is the calculated interest that would be stored in SI. And all of this are of float data type, or make it as double if you want to store a bigger number. What does it do? The float data type will have both the integral part as well as the fraction part, right? And these are the variables what I have created, and with class it would be called as data members. These are data members I have created for storing principal, time and rate of interest, and also for storing the calculated SI in the public section. Public is an access specifier. Anything whichever is declared in public can be accessed outside the class. It is accessible everywhere just by creating an object of the class, and with the help of the object you need to use the dot operator, then the function name would execute that. Then I have three member function declarations here. One is input, one is compute SI, and another one is display SI. I have declared, I have not defined it here. I have only function declarations, and all the three functions are not going to return any value, and I am not passing any arguments to it. Void is the function does not return any value. So I have all the three void functions, and since this open and close brackets, I don't have any arguments here. So a function without return, without arguments, all these three belong to that category. And then I have declared it here. I need to define it outside the class. So I'm terminating by my class over here with a semicolon. A class should be terminated with a semicolon. So the class simple interest has 4 data members declared in the private section of the class and 3 member functions which is declared in the public section of the class. So any doubts here? You please go through that. You shouldn't have any doubts over here. And next, I am declaring it inside. I have declared it inside and defining it outside the class. So it's a commonly asked question. They will ask you, like most of the time, either declared inside and defined inside, or declared inside and defined outside the class. So I'm defining the function input compute SI and display SI outside the class. How do I do that? The return type of the function for input, what is the return type? It is void. I'm saying that the function does not return any value. That is why it is void. Void name of the class in which it is declared, or name of the class to which it belongs to. So where is input declared? It is declared in the public section of the class simple interest. So input belongs to simple interest. That is why the name of the class to which it belongs to, scope resolution operator. 2 colons is scope resolution operator. Don't put semicolons over there. And then the name of the function and the argument list if any, since there are no arguments, because it belongs to no written, no argument category. So there are no arguments, but the name of the function is input. This is how you define a class outside. This is the getting it? How do you define written type, name of the class to which it belongs to or in which it is declared, scope resolution operator, name of the function, and argument list if any. But then this does not have any arguments. I am not having anything over there. Then I write the body of the function. The function body is returned between two curly braces, but then it is not terminated by a semicolon. Only a structure and a class gets, like till now whatever we have used, a structure we have used and a class we have used. Structure and a class gets terminated by a semicolon. So here what am I doing? Cout ender. One new line. I am asking the user to enter the principal amount, time and rate of interest. PTR. I am asking the user to enter the principal, the time and the rate of interest, and ender. The cout statements are very necessary, because as a user, if I directly put in the C in statement, I will not know what I should enter, in what order, and how many variables I need to enter. So here it is explicitly specified. I need to enter first is what? Principal amount. The second which I need to enter is time, and the third is rate of interest. So I need to enter three values, and these are the ones. First is the principal amount, the second is time, and third is the rate of interest. And then I am taking all the three PTR. Where are these declared? It is declared in the private section of the class, and they are data members of the class. So in one cin statement, I am taking all the three. That is called cascading of input operator. What is it called? It is called the cascading of input operator. Then I have that completes my function input. That is, I need to just take in the input values. I am not taking for SI because I need to calculate SI. To calculate SI, that what are the things I need? The principal, the rate of interest, and time period. I need to use the formulae for calculating, and whatever is the result of the calculation has to be stored in the variable SI. So after that, void, I am writing for compute SI. You need to compute it, right? Void is the written type of compute SI function, name of the class in which it is declared or to which it belongs to is simple interest, scope resolution operator, and the name of the function. So why I have put 100.0? Because since all others are float value, so I've put this also as a float instead of putting it as 100. So SI is equal to P into T into R by 100. Whatever is the result of that would be substituted in SI. That is, first the RHS is computed, and whatever is the result of that computation is stored in the LHS, which is SI. So SI can have point values because I have declared it as float. Next, I've completed here. I don't have any cout statement here. I'm only computing SI here. Now I have a function separately for displaying SI. So what am I doing here? Cout ender principal amount P, along just not only displaying the simple interest, I am going to display what is the principal amount you have entered, what is the time period, what is the rate of interest, and then the calculated simple interest. This needs to be written this way. It's like it has to be explicitly, anybody sees this, they should know what was the values entered, what you are doing, what you have calculated, and what you're printing. So we finished all the three functions which are the part of the simple interest class. And then every program to execute should have a main function, which is a library function. If I don't specify anything, it becomes int main. Then you need to write return 0 in the end or void main. Main is not called anywhere, so it does not return any value. Clear screen would clear the output screen after each execution. First thing, what I need to do, whenever I have a class program, I need to create an object for the class. Otherwise, without an object, you cannot access the data members or member functions depending on where they are declared inside the class. You cannot access it, and memory would be allocated when you create the object of the class, and also the default constructor will also get executed. The general syntax of creating an object is class name space the object name. So simple interest is the name of the class. I have given as a name of the object, and then using the dot operator you need to call the functions in the proper order. That is, if I call compute SI before calling input, it will not give me a proper result. It will give me junk values because I don't know. I'm using in compute PTR. First of all, you have not taken that values from the user. How can you compute? So order in which it is called is very, very important. Order in which you write is not important. I can write the first is compute, then display, then input, whatever way order I can write. But when you're calling the function, the order is very, very important. So first I created an object, and then I call the input, compute, and display function. Get ch would wait in the output screen for a input from the keyboard, and then I complete my main. Right? Please have a look. Now we'll execute it. Run. Enter the principal amount, time, and rate of interest. For example, if I say 5,000 is my principal, the time is 5 years and 5.5. The rate of interest is 8.75. So you can see here it is showing me principal is this, the time is this, rate of interest is this, the simple interest is 2406.25. So this way you need to write the output. You can have a look at the output. And then it is waiting in the output screen until I press a key on the keyboard. So it goes back to the source program. If I take out get ch, what happens is it will execute and come back. You have to use Alt F5 to view your output. Hopefully you have understood the 6th lab program. The next lab program is, please make a note of the statement. Write a program to find the cube of a number using inline functions. So we have done inline functions in function overloading chapter. So what are inline functions? Whenever there is a function call, instead of the function call, the function call is replaced by the body of the function, is an inline function. Getting it? And it is only a hint to the compiler. But then if there is no memory available during runtime, it will have only the function call there. So write a program to find the cube of a number using inline functions. Write down the statement so that we can proceed with the execution of it. Yeah. So this is an inline function. Class inline function. Class is a keyword. Inline function is the name of the class. It's not any keyword I have given. Since I'm going to use inline functions here, inline function concept, I have given the name of the function as inline functions. Then private. Private is an access specifier. So anything declared in private is not accessible outside the class. It can be accessed only by the member functions and the friend functions of the class. So in the public section, I have a constructor. Why is it a constructor? Because this does not have any return type, not even void. Right? Inline function is the name of the class and inline function is name of the function also, which does not have any return type and declared in the public section of the class. That is why it is a constructor. Constructor is a special function which is declared in the public section of the class, which do not have any return type and have the same name as the class name. And I'm going to pass one integer parameter to it. That is why it is a parameterized constructor. Constructor, that is parameterized constructor, is one to which we are going to pass a parameter. That is why it is a parameterized constructor. Constructor without parameters is default constructor. So I'm going to pass an integer parameter to it, and then I do have a data member which is int num. Num is the variable which is an integer which is going to hold an integer value. Then I have int cube. Cube is a function to which we are not going to pass any arguments and it is going to return an integer value. Cube is a function which is going to return an integer value to which I am not going to pass any arguments. So these two are the member functions. Like this is a member function, this is the constructor. Since it has one parameter, I'm going to pass one parameter to it. It's a parameterized constructor. This ends my class over here. Now I'm defining the constructor. Outside the class there is no return type, so the name of the class, scope resolution operator, and int n. N is the formal parameter. What am I doing? Where am I passing this n from? When I create an object, either a constructor can be invoked using implicit call, explicit call, or equal to. So whenever I create an object, I need to pass the parameter as an argument to it, and I can pass it in implicit, explicit, or by using equal to, since there is only one argument here. And then what am I doing? I'm just assigning the class variable. I have num is equal to n over here. I'm not doing anything. Whatever is the value of n is substituted into num. Then I'm closing my constructor over here. Since they are functions, you're not terminating it with a semicolon. And then I'm declaring an inline function cube. Inline is the keyword which states that it is an inline function. Inline, since it's a keyword, it has to be in lowercase only. Inline int is the return type of cube, and then the name of the class to which it belongs to or the class in which it is declared as inline function, scope resolution operator, and cube. Return num star num star num. Num, from where will I get? It's Like over here, yeah, in the constructor, whatever is the this thing past value is assigned to num. So I'm going to return this at the place of the function call. Wherever is the function, from wherever you call the function, at the place of that, this value gets returned. Either you should have a variable of the same data type of the return type as the return type to hold it, or you can write it in a cout statement. It is up to you how you write it, or whether it's not a, I can say whether you want that value for further calculations or not, it depends on that also. So inline, this is the keyword which states that it is an inline function. Okay, then void main int n, I'm having an integer value, I'm taking in, enter the number to which you want to find the cube, like asking the user to enter the number you want to find the cube of. Seeing in n, I'm taking in the value from the user. And what am I doing here? See, I am doing inline function if. What am I doing here? I'm creating an object. Since this is a class program, without object you cannot call the function. I will call the function cube here, but then the constructor has to be invoked either in an implicit or an explicit, or by using equal to in case of parameterized constructors. In case of default constructors, whenever you create an object, the default constructor gets executed. So I'm using the implicit way of passing. That is, I'm creating an object. How do I create an object? Name of the class, space the object name, and then I'm passing n to it. Getting it? So when I pass n, it will execute. Like this is the implicit way of calling. How do I use the explicit way? Let me try that out. Inline function if1. I cannot use the same object because double the creation, it will give you multiple declarations error, so you need to change the name. Then is equal to n. This is using equal to, or if I'm using inline function if2 is equal to this is how I create the function, right? So I can say so this is how I can write it, because I need to call it using different functions. So I can see you will write only one, but I am showing you how you can use it. Like this is implicit, this is with equal to, and this is with explicit call. How you can pass. And this is the end of the program. Enter the number. For example, if I write 5, yes, first time is implicit call, 125 it is showing. Second time I used the equal to and I did not pass a new value to it. I passed n only, which was 5. So it is showing me 5. And third one, I'm using the explicit call and I'm passing n only, which was 5. So it is showing that way. Or let me, so you wouldn't need that many. This is for your understanding. I showed you. So you can write only this. Oh yeah. Enter a number for the cube of 4. 64. Yes. I took out all the function calls. That is why you got only one. You need to write only one, like whether you use implicit call, explicit call, or you equal to. Suppose if the examiner asks you to do the same thing with explicit call or using equal to, I just showed you how to do it. Fine. Hopefully you have understood this. So we'll close it. Quit. So hopefully you have understood two executions. Tomorrow's class and day after maximum I would be completing the execution of your all lab programs. So we'll come to an end of all the 16 program executions and explanations. Then we'll start with Boolean algebra, which is also very important. 100% K-maps, you will get one question and also you will get 3 and 2 markers from this chapter. So Boolean algebra and logic gates are important for your exam point of view also. Please note down the homework question for today. Write a, I can say learn and write a program to search for a given element in an array using binary search method. Please make a note of this. You need to learn it and write it because these programs will be not taken out from your lab exams. They will not take it out, so you need to know all this. So take care, stay safe. See you tomorrow. Tomorrow's class, please keep a book handy so that you can note it down. Okay, see you tomorrow. Bye bye.